So today, what we are going to do is to implement a convolutional neural network for image segmentation application, right? So I will provide you this data set. This data set can be downloaded from the internet and it's freely available. I think this is provided by the Microsoft. Uh, and here we have two main categories of data, images actually. So here altogether we have 25,000 images of cats and dogs. So to be specific, sorry, we have like 12,500 dog images and 12,500 cat images, right? So a considerable amount of data is here, right? So what we are going to do, what we are planning to do now, early year, previous weeks we trained neural network. We trained a few neural networks, and we use some small data sets, right, and some standard data sets. But here, this is a customized data set, our own data set. I mean, not our own, but a customized data set. Right, so where we have raw images. Now, we are going to start everything from the very beginning. Now, this is the standard method that you are going to follow when you are training a convolutional neural network, right? When you are training a convolutional neural network. So we have a set of images. Now, we are going to train it and see how the performances how the performance is, right? So we have, as I mentioned, we have the raw data set. So we have to do everything from the very beginning. I mean, everything from scratch. That we have to train the neural network. Before training the neural network, we have to process the data, and we have to process the data set, and we have to like resize the data set, and we have to do lots of things, right? So we will see from very beginning how to implement this kind of convolutional neural network and how to train the convolutional neural network for this kind of application, right? Okay, so what I'm going to do with the Jupyter notebook, I'm going to start a code and note that uh, I'm in a folder like this. So the pet images folder is there. Inside that you have the cat images and the dog images set. And here is my first code. Now in this code, what I'm planning to do, trying to implement uh, the data be processing. I mean, I'm going to process all the data and like create the data set. So in this code, I'm planning to create the data set. So after that, we can apply this into the convolutional neural network and train it, right? So first we have to process the data, and now we can't directly apply the data set into neural network. We have to process, since this is our own data set, not a standard data set, right? Okay. So please, if you have any questions in the middle, as I mentioned, always you can interrupt me and ask questions if you have any questions, right? Okay, so we'll start, and we have like 14 participants here. Hopefully others are on the way, let's assume. Okay, so what I'm going to do first, I will try to read all the images, right? So mainly this is the plan. Uh, right? So before applying, I will give you the basic plan. What we are going to do, we are going to get an image, right? An image, right? And then apply it to a CNN, a convolutional neural network. We are going to train a convolutional neural network, and at the end of the convolutional neural network, as usual, we have two neurons for cat and dog, right? So this is what we are going to do. We are going to apply a data set, right? Sorry, an image, and the convolutional neural network is going to predict whether this is a cat or a dog, right? So like this, 0.9, right? So it's going to give us a probability, right? It's going to give us a probability of whether it's a dog or a cat, right? So that's the basic plan what we are trying to implement, right? Okay. Now another thing that before training this neural network, we need to we need to pre-process the data, right? So data set should be pre-processed. So what do you mean by pre-processing is this. Now we have, as you can see, we have lots of data here, right? We have lots of data, I mean images here. And the most important, sorry, the other thing is that these images are not in a common size, right? So you can see they are in the not in the common size, not in the common format. I mean, there can be JPGs, JPEGs, and PNGs, right? So different type of images could be there, right? And yes, different set of images could be there, and yeah, so that's the most significant things. And sometimes there might be like some corrupted, damages images, so we can't manually inspect them, right? So when you are going to deal with this kind of a data set, you may have like corrupted images and some text files can be there, right? So you can see here, good, I found one. Now can you see this 835, right? So this is an empty image, right? So I mean, somehow it's included in the data set, but nothing there in the data set. Uh, so right? So nothing there in the data set. You can see that this is empty. So this kind of things can be, this kind of issues can be there. Understood? So we have lots of issues when we are dealing with this data set. The most important thing is that we can't manually inspect these errors, right? So we can't manually inspect for these errors, right? So that's one other disadvantage. So what we need to do, like we need like have a programming approach. We have to write a code to do whatever the pre-processing things, right? Okay. So mainly what I am planning to do in data pre-processing. So the first code will be data pre-processing. So we are going to first pre-process the data and create our data set, right? So in this one, I'm planning to implement, I'm planning to do lots of things, right? So the first thing is to, right? So I will, yeah. So data pre-processing and the data pre-processing, what I'm planning to do. Now this is the common approach, right? So you are going to get an image, and this image can be in a resolution of n by m, right? N by n resolution. I mean, we can't exactly say what's the size, right? So what we need to do first, we have like, uh, right? We have to uh, convert it to a fixed size. Let's say 50 by 50, right? 50 by 50. Now, don't think, okay, 50 by 50 is low resolution, right? No, don't think like that. Since the NVIDIA self-driving car is also using 200 into 66, 200 into 66, 66 rows and 200 columns image, right? So, uh, I mean, the resolution is not that much a matter since the convolution neural networks we discussed last time, they are going to extract features, right? I mean, they can see features than us, right? Since it's the kernels are very sensitive for the features, right? So you can see it can like detect tiny little edges as well, tiny little features. So the resolution is like 50 by 50 is quite enough. I mean, if the resolution is not enough, if we are not uh, if you are not uh, if you are not obtaining the accuracy or the performance we expected, then probably we can increase the size, right? Okay, there are people with the cats. It's okay. No, that's not okay. Okay, so good question. There are people with the cats. Is it okay to take images like that? Will it affect? Yes, not exactly, but yes, it is. But the theory or what we are assuming is that okay, I mean the convolutional neural network is going to like train for identifying features, so it's going to see most of the cats, right? Most of them are cats, so it's going to like extract features. So we will think it's like this now. Since it's going to extract, since it's going to like uh, like I mean uh, my point is that it's like can you remember in the self-driving car now when we are like the camera is or the captured image of trees, it's not going to detect features. So likewise, when a human is there, we assume that it's not going to extract features from human, right? Only features will be extracted. So that's the assumption. But the thing is now, this is not the most advanced image object detection method. Now this is actually a low level method of just training a convolutional neural network. But I will discuss about this proper application on next week practical session. That how to train an object detection API. Usually, we are not going to apply the whole data set, the whole image. We are going to like segment where the cat is, right? So we need to like segment where the cat is. I will discuss about that thing later, right? So how to like perform object detection. Now, in this case, like we can't get a bounding rectangle around the cat or a dog. Cat hari dog hari වටේට rectangle එකක් අපිට අඳලා ගන්න බෑ මෙතන. Right? So this is like a basic method of implementing a neural network for detecting cats and dogs. But we have some advanced application. I mean, advanced methods where like we can directly get the bounding rectangle. Then we can detect. Okay, so this is the cat. We can segment the cat and detect. So those kind of things will be done under object detection APIs, and those things will be covered in coming weeks. Now, my point is that there is issue now. Humans are there, but in the standard method, the advanced method, what we are going to cover on next week, we will crop it. Right. So when we are going to train it, we will crop whatever the object we are interested. Right. But today, this is just we are implementing a convolutional neural network to see what's going to happen. Right. Okay. This is not the standard method of doing this anyway. Now we need to resize it, and probably now this is optional method, not applied everywhere. We need to like convert it to grade. Sorry, I will write it like VGR to grade. Now this is an optional thing. I mean optional in the sense now if you are what you are going to make අනිවාර්යෙන් කරන්න ඕන දෙයක් නෙමෙයි. This is depend on the application. Now if your problem what you are trying to implement in this or in your application, if let's say the convolutional neural network, we are going to train a convolutional neural network. So in this problem, if the color is not a critical feature, you can convert it to gray. The images can be converted into gray. Now, what do you mean by critical feature? Now, in order to detect cats and dogs, right? In order to detect cats and dogs, is color a critical feature? In order to detect cats and dogs, color now is, I mean, the prediction whether cats or dog is dependent on the color. Yes, we have answers. Let's see. No. Okay, I'm going to design a neural network which is going to classify fruits: apple, banana, pineapple, and papaya. Right, let's say. Okay, in that case, is a color a critical feature or critical attribute? Yes, exactly. Right. So in that case, color is a critical attribute, right? I mean, color, yes. I mean, okay. So let's say, okay, tomato and apple, right? I mean, okay, orange apple, right? Or guava apple, right? I mean, they are in the same shape, right? But the color is the only discriminating factor. Understood, right? let's take, okay, let's take, I mean, orange and tomato, right? Tomato is considered as a fruit some parts of the world. Now, my point is now in that case, the color is the only, like, I mean, the shape and the other stuffs are quite the same, right? So in that kind of a thing, the color is going to be a matter. But some application, the color is not going to be a matter in this kind of a case. Now, in face detection, is color going to be a matter? Face detection, identifying a face. Yes, yes, face detection. No, color is not going to be a matter. Also, we are not going to use color images in face detection since now we have like different ethnics and different regions, right? So we have different skin colors, right? But still, now what convolutional neural networks or whatever this classification algorithm is looking for is features. But sometimes color is also a feature. Color is also a feature. But most some of the application color is not a feature, right? So faces we have like say, different skin colors, right? Okay. Yes, so that's totally dependent on the application. So keep that thing in mind, right? Okay, so this is optional thing and depend on your problem, right? And right, so uh, and we have like right. Also, we have to uh, remove the corrupted images, right? We have to remove the corrupted images as well. Now, sometimes there might be corrupted images, right? There might be corrupted images in the right. So remove uh, corrupted images, right? Corrupted images. So that's it, right? I mean, some of in the some of other cases we need like do more advanced advanced steps, but here this would be enough, right? Okay. So what you are going to do now? This is quite important. What I'm going to implement today. Yes, we will deal with the CNN example where the color matters on next week, Tuesday. We will train a object detection API for custom object, right? Uh, so in that case, we are going to deal with color images on next week. So next week section is quite important. What we are trying to do is to train a convolutional neural network for our own object. Right. So if you have suggestions and if you have like data set, if you could find a data set, you can suggest me. So I will train uh, the neural network for that. Let's say a watch, let's say a banana, let's say anything, right? So if you could find a data set and if you have a suggestion for an object, so please drop me a message. So I will try to train the neural network for that. So this is quite important. I mean, we can train convolutional neural networks for any to detect almost anything, right? So we'll talk about that thing on next week. කාට හරි තියෙනවා මොකක් හරි මේක ඩිටෙක්ට් කරන්න පුළුවන්ද කියලා ඒ වගේ data set එකක් හොයාගන්න පුළුවන් නම් මට කියන්න මම try කරන්නම් ඒකට train කරන්න, right? Otherwise I'm going to use kind of like tomato or whatever the customized kind of thing, right? A fruit or whatever thing, a bus, a car, it could be a car, it could be a bus, it could be a watch, it could be anything. But the thing is now you need to have lots of data, lots of images. Anyway, the next point, now we are going to implement the code. Now, the most important thing that here, we are going to do this in a very standard way, right? A very easy and a professional development method we are going to follow, right? So please keep a eye on this, the way I'm trying to implement this code, or the important thing is the pre-processing code. right? So I will use some standard methods of doing this, right? Okay, so what I want to do is I want to read the data set, the images one by one to this code. I'm going to read, load images one by one here and resize it, convert it to gray, check whether this is a corrupted image. And if it is not, I'm going to pass it to the data set, right? I'm going to pass it to the data set, right? Then take the next image, convert color, resize, check whether corrupted image, pass it to the data set, right? So that's what mainly I'm trying to do, right? Uh, so as we mentioned, we are going to take an image and resize it, right? And RGB to gray, RGB to gray, and then we are going to add it to the data set, right? So that's what we are planning to do. Okay, quickly, we need to use the OS library, the operating system library, a quite helpful library in this kind of cases. So I will import it, import OS, import OS. Then I'm going to create a variable called data path, right? So I have given the data path. Now I am here, the code is here, right? And this is where my data is located. Now it can be anywhere from your computer, doesn't matter, right? So you can give the path. I mean, you can give the path as this as well. I mean, right? I have discussed about these things. So we can give the path like this as well, right? But if you are going to give it like this, put the R before. Otherwise, you have to. If you are not going to going to include this R, then you have to manually convert these slashes back. I remember I discussed about this thing. Right? Okay. Then what I'm going to do? Okay, categories. So I'm going to get the categories. Okay, so I can do it like this. Okay, how many categories are there in this problem? How many categories or how many labels are there? Yes, two, good, right? So you can do it like this as well, right? You can do it like this as well. Okay, cat, dog, right? So manually. But what's going to happen if you are going to do it like this? If you are going to add another class, let's say rabbit, you are going to add a rabbit folder here, right? Then what is going to happen? You need to change the code again and manually add the rabbit here, right? But I'm not going to do it like this. I'm going to use a dynamic method. See, os dot list directory data path. Os dot list directory data path. So let me print the categories and show you. Right? Understood. Now, what's going to happen? Why I'm saying this is dynamic? You are going to add, let's say, a folder rabbit, and let assume that you are going to include some photos inside the folder. Right? What do you have to do? No change. Run it again, right? So os.list directory, what's going to do? It's going to go to the provided path here and take the file names or the folder names, whatever the items inside this path. මේ path එකේ තියෙන items ටික ගන්නවා. අරගෙන it's going to include it in a list, right? So the file names or the folder names will be included as elements in a list. List එකේ elements විදිහට වැටෙන්නේ මොකක්ද? ඒ folder එකේ තියෙන file names, folder names. Understood, right? So I will remove this thing since it's not the actual. Right? So a dynamic code, it works for any update. So that's the most important thing now. The code will be implemented as this. Order always ascending. Yes, I'm not sure about that. Most of the signs it will be like alphabetical order, I assume. I think, but we can take it as like sort by type, sort by type also. I'm not sure about how to do that, but most probably it could be done. I will check it and let you know, right? But usually I think it's coming in the alphabetic order, alphabetic uh, ascending order, right? So now what we need to do now, these are the folder names, right? But we need to have what? We need to have labels, right? 0 and 1. Can you remember? Right? So we need to have 0 and 1, right? So what we can do? We can like, okay, cat is 0, dog is 1. So how we are going to do that? Let me take like labels equal uh, os dot, sorry, uh, np dot o arrange yeah, but I think we can use, no, let me use this I4 I in range length of, right? So length of categories, length of categories, right? Length of categories, understood? uh, okay, right, length of categories, and let me print uh, the labels, right? Right. So what I did now, length of categories is 2, right? So I'm going to create a label. Now I did this kind of a similar thing on the first week practical, right? Can you remember creating arrays using loops? Now I for I in range this. Now what's going to happen, right? So now what's going to happen? How many four folders are there? It's going to create 0. Now it says okay, 0 is cat, 1 is dog. We can use the labels. Now I need another thing. I need this. I will later let you know the usage. I will later show you the usage of this, the advantage of having this kind of thing. Category dictionary, right? Category dictionary. I think you can remember how to create a dictionary using keys and values separately. Now this is why I told you, like, so everything is connected. Every week is connected, right? Can you remember when we are having like keys and values separately? You can use this method to create a dictionary using that, right? Uh, yeah. So I will create a dictionary like this: categories, categories, sorry, categories and labels, right? So I'm going to create, I'm not, I will show you the usages of these things, what the purpose of having these kind of three arrays and dictionary, categories, labels, and category dictionary. I will show you the usage later, but I will first implement it and later I will explain, right? Okay. So now what I need to do, as I mentioned, I need to go through each and every image, right? I need to go through each and every image. But before going on each and every image, I have to go each and every folder, right? First, I have to go through each folder. First, I have to go through this folder, and next I have to go through this folder, images of that folder. Now, how to do that? Uh, what you can do is for category in categories. Okay. Now, can you tell me how many times this loop will run quickly? Yes. Or be with me. Two times, good. Okay, now for each time category will be, the first time category will be what? First week knowledge category will be first time the category will be what? Cat, right? Cat. Good. If you are not sure about this, see, right? Cat, dog. Right? Okay. Now, okay, we have to do lots of things here, as I mentioned last time, uh, earlier as well. The thing is now, last time we just, okay, the MNIST data set we just got and the Excel file we just got. No. When we are dealing with images, we have to do lots of things. We have to create our data sets manually now. Here we are creating our data set now. Still we are creating our data set. We are not going to train the neural network at once. We can't do that. First we have to create the data set, right? So when you are coming to your own problem, there is lots of things to be done prior to training the neural network. Neural network train kan කලින් ගොඩක් දේවල් අපි කරන්න වෙනවා. Right? So this is example, good example. Okay. So what we need to do, okay, I will get the image names. Okay, let me take image path. Image path equal os.path dot join data path and category, right? So what I'm going to do, I'm going to join the two parts and create the new part, create a new path called image path. Let's see. Now you know what's category. I'm going to join it with the data path, right? So can you see? Now it's created, it's going to create a new, what you call, a path, right? Path එක හදන අලුත් path එකක් හදන loop එක දෙපාරක් කරන්න වෙනවා දෙපාරට paths දෙකක් හැදෙනවා, right? Understood, right? So two paths will be created. Now let me read and get the file names of the images. How you can do this? Image names os.list directory, os.list directory, image path. So what's going to happen? First, right? So what's going to happen? First, it's going to, now the image path will be what? Blah 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 pet images slash cat. The පළවෙනි පාර path එක වෙන්නේ ඒකනේ. test image, sorry, pet images slash cat, right? So we are going to like take that path and read all the items inside that path and save it in an array, right? Okay, can someone tell me what will be the size for this image names array for each case? I mean, for, okay, so I mean for each run, right? Can someone tell me, can someone tell me what's the size of the array of image names for each instant? I mean each instance of the for loop. Yes. මේ array එකේ size එක කීයද? එකපාරකට loop එක run වෙන එකපාරකට කීයද? Number of images, yes, number of images. ඒ කියන්නේ 12500යි කියලා මම කිව්වනේ, right? Can you remember? Okay, good, right? So images names will be a list of image names, not images, image names, right? Not images, image names. Okay, now okay, so how many times this loop will run? The second loop, the inner loop. How many times? How many times this loop will run? Yes, number of images, right? So cat, this will run once, and for cat, this will run the number of images of the cat folder. Second time, dog, this will run for the number of images in the dog folder, right? And now what I'm going to do? So, right, so let me print it. Sorry, this should be IMG names. So you can see, right? Understood. Okay. Now I want to load it to my computer, image one by one. Okay. Can someone suggest me a code to load the image? Yes. Can someone suggest me a code to load the image into my program? Single image by single image? Yes. Good. cv2.imread. Good. Okay. Okay. Image equals cv2.imread. Okay. Probably I have to import the cv2 module. Okay. Now, can some other give me the path to be given inside the imread method? What should be the path to be passed to the imread method? Yes. Yes. Image path plus image name. Good. So os dot path dot join image. Okay. Now, why this is not going to work? Why this is not going to work? Now, what is image name? It is like for cat and dog. Let's say first cat. Okay, it will be 0.jpg, 1.jpg, 2.jpg, likewise. Right? Now, why it's not going to work? Okay, so if you are going like put image, sorry, 0.jpg, 1.jpg, it's going to look here, right? I mean, it's going to look for 0.jpg here. Now, can you see a 0.jpg here? 1.jpg here? No, it's not here. It is in the pet images. That means the data path or the images path, image name, right? So that means we have to do what here? Yes, right. දැන් මෙයා 0.jpg කිව්වොත් මොකද වෙන්නේ? මෙන්න මෙතන තියනවාද කියලා බලනවා. ඒ කෝඩ් එකේ තියෙන තැන බලන්න. එතන 0.jpg 1.jpg කියලා එකක් නැහැ. එහෙනම් මෙන්න මේ data path එක ඇතුලේ images path එක ඇතුලේ දෙන්න ඕනේ නම විදියට නේද? එහෙනම් අපිට මොකද කරන්න? එහෙනම් අපිට කියන්න වෙනවා මෙන්න මෙහෙම. os.path.join image path කියන්නේ pet images cat ඒකට join කරන්න image name එක 0.jpg වගේ. So that it like image name, right? Understood. Okay, now we have the image. So let us check it. cvd.imshow. And let me keep a small delay between these things. And right, so then if he is equals to 27, let me break it. And so this is something you know, right? cv2 dot wait, sorry, cv dot destroy all windows. Okay. Let's see. Now it's loading image one by one. Right? Image one by one. Right? Okay. Now we have a issue here. Now it ended with an error. Right? Can you remember that I told you, okay, there might be images, corrupted images, or any kind of any issues. Sometimes now this is trying to read images, right? So what happens if there's a text file? Can cv2.im read that? Like text file එකක් එහෙම මේක ඇතුලේ බැරලා තිබ්බොත් yes, you can. Okay, can we use it as image path, image name? Yes, you can. You can use it as this as well. You can use it as image path, but you have to add this manually. That's the issue. Image path, this thing, or this plus like this, right? But it's good to use this thing, right? Okay. Now regarding this, now this is the error. Now let's assume that there is a text file or whatever unsupported file to OpenCV imread function. It's going to give an error. Now the thing is, we are dealing with 25,000 images. So usually it takes few minutes to read all of them. But the images 25000 කියවන්න සාමාන්‍ය විනාඩි 10ක් 15ක් යනවා. ඊට අඩුයි. Let's say විනාඩි 10ක් විතර යනවා 10 minutes, right? So what's going to happen? Now let's say that okay, this is going to give an error and the code will be terminated in middle of the reading, middle of the image reading, right? Image reading when a magadi make a navathino, right? So like let's say if you are spending 10 minutes for this, so that's like a huge loss, right? So we have restart it again, and manually we have to search it for the manually we have to search for the corrupted file or the not unsupported file and remove it, right? So in that case, what we can do, no need to do this. We can use exception handling. We can use exception handling, except, sorry, we can use exception handling. We can use a try block. So what's going to happen when we have like a try block? What's going to happen if there is any error, right? If there is any error raised, so this is a common concept in almost all the programming languages, right? So the thing is, now if an error is raised, what's going to happen, right? What's going to happen if error is raised? It's not going to terminate. Now earlier it's terminated. කලින්ම code එක නවතිනවා. error එක දිහා නවතිනවා. හැබැයි try block එකක් ඇතුළට අපි code එකක් දැම්මොත් try block එක ඇතුලේ code එක error එකක් ආවොත්, right? try block එක ඇතුලේ error එකක් ආවොත් එහෙනම් මොකද වෙන්නේ? it's not going to give an error. Instead of that, it's going to like come to this except block method. So what we can do, we can see what's the error. Except exception as E. So we can print the exception, and that's it, right? So that's what's going to happen. That's only what's going to happen. So it's not going to get terminated. Okay, let's say that we have a corrupted image here. What's going to happen? It's not going. It's not going to terminate. Instead of that, it's going to come here and print the error and go to the next image. It will not be terminated, right? So let's see. I will reduce the delay as well, so you can see. Now can you see? There is the error, but it's not terminated. The error is printed and code is still running. Won't we use finally here? I'm not sure whether it's available in Python. Is it? I'm not sure about that finally. I think it's available, but you can use, but this is sufficient, right? This is sufficient. It will solve our issue, right? So I mean, if there is any error is printed, it's not going to be terminated, right? Okay. Now we know, I mean, no need to show these things that I showed it to verify that all the images are loaded. But what we need to do is to resize and convert it to gray, right? No need to show these things. I just showed them to like verify this is working correctly, right? Okay, so how we are going to convert it? You can convert it like this: gray equal cv2 dot convert color. This was available in the tutorial. I hope that you have gone through that tutorial one. Gray image, and we need to mention the color flag. So color flag is cv2 dot color bgr to gray. So we have the converted image, the gray color image, right? The gray color image. And then what we need to do, like we need to resize it to a common color, common size, right? Resize. I mean, we can use the same object, right? No need to create everything new. Image equal cv2 dot resize. I'm going to resize the image into let's say 50 by 50. Right, 50 by 50. Oh, it's better if we can define the image size here. So then no need to change everywhere. If you, I mean, if you want to change it, no need to change it everywhere. Right, වෙනස් කරන්න එහෙම වුණොත් එහෙම හැමතැනම වෙනස් කරන්න ඕනේ නැහැ. මෙන්න මේ image size එක දාලා තිබ්බනම් ඒතකොට image size කියන තැන වෙනස් කරා නම් මෙතන, so it's sufficient to change here, so everything will be changed. So I'm going to resize it, and that's it, right? So that's what I mean. This is, as I mentioned, this is a basic convolutional neural network implementation for image segmentation, right? A basic level. So this is enough in the basic level. And now what we are going to do, I'm going to I'm going to create two Python arrays called data and target. So what we are going to do here, so these are Python lists. You can see Python lists, two Python lists. So I'm going to append the image. So can we append images? Yes, I mentioned this in the first week as well, right? So I'm going to append the image here. Okay. So target. So I'm going to create the data set. I mean, image by image, I'm going to add it to the data set. Okay. Can someone tell me, okay, what should be appended to the target? Target එක append කරන්න ඕනේ මොනවද? Yes, the category, right? Okay. Can someone give me the code here? What should be appended here? Can someone suggest me the code quickly? So we need to append 0 or 1. Right? We are not going to append like cat and dog. We need to append 0 or 1. Later we can convert it to the categorical form. We will later convert it to the categorical form, but now we need to append whether it's 0 or 1. Yes, anyone? Can someone suggest me what to be appended here? When it's a cat, we need to append this. When it's a dog, we need to append category 0. Okay, category 0. So category 0, if you are going to append category 0, that will be cat. Always cat. For dog images, also you are going to append cat. Yes, can someone suggest me what to be appended here? I mean, it's whatever thing that you are going to tell me should work for both cats and dogs. Label category, label category, label category. No, not label category. Close. I mean, okay, when you are reading a cat image, 0 should be appended. When you are reading a dog image, 1 should be appended. I mean, you can keep a track on what you are reading, right? ඔයා මොකද්ද read කරන්න කියලා ඔයා track එකක් තියාගන්න පුළුවන්. මොකද අපි ඉස්සල්ලාම යන්නේ dog එකේ ඊළඟ යන්නේ cat එකේ. So we are going to first go through cats. Secondly, we are going to go through dogs. So we can keep a track. Okay, we can keep a track. What's this image? මේ read කරන්නේ cat image එකක්ද dog image එකක්ද කියලා අපිට category එකෙන් බලා ගන්න පුළුවන්. We can inspect it from the category. We know whether this is a image of cat or image of dog. We can keep a track using the category. Yes. Yes, good. Category dictionary, category. Right, see? So that's the purpose of having this category dictionary. Category dictionary, label. Yes, good, right? Now what's going to happen? Okay, when we are reading a cat image, the category is in the category. I mean, the category is in the cat. Category is cat, right? Category is cat. So now what we are going to do? We are going to append category dict cat. So what we mean by category dict cat? Category dict cat is 0, right? When you are going to write, when you are reading a dog image, category is dog. Then category image dog is 1. So it's automatically going to append 0 or 1 depending on the image you are reading, whether it's a cat or a dog, right? Understood? So if you run this, so we have where a label is not defined. Sorry, I made a mistake. This should be category did category. Hi. Okay, so this takes a few minutes. You can see now we are going through like 25,000 images, right? So it will probably take few minutes to run this. Right? Okay, any unclear point up to now? So we just created the data and target, right? So we are like looking for 25,000 images. We are going through 25,000 images and we are loading one by one and resizing it, converting color and appending to the data and target, right? So in data, you have 50 by 50 images. In target, you have whether that image is 0 or 1. 0 or 1 in the sense cat or dog, right? 0, 1 in the sense is there is a cat or a dog. Understood? Right? Okay, so this will let it run, right? 50 by 50 resize or crop, it's resizing, not cropping, right? So resizing, you know, right? So what we are going to do, we are not cropping, we are resizing it. That means, okay, let's say if we have this kind of image, let's say, okay, 200, 150, we are going to resize it to 50 by 50, right? We are not going to crop it, we are going to resize it, right? Not cropping, it's resizing. I will show you one resized image, then probably you will understand. Okay, all right. Okay, yes, so then let me show you one image. Import, it should be from matplotlib import plot as plt. So plt dot show data 0. I will show you the first image, data 0. plt dot im show, sorry, im show. CMap equals script, right? Okay, so then what we have to do, few things. Uh, so can someone suggest me what are left to do here, right? What you need to do again? I mean, before saving the data set, before saving the data and target, is there anything to be done? Right, so can you see? So this is a resized image. Yes, good. Pasunju, now we need to convert it to the categorical form, right? So it's 0 and 1. We need to convert 0 into 0, 1. Sorry, 1, 0. Right, so probably you can remember these things, right? I mean, in order to remember these things, you need to be with the, I mean, the things that I'm going to cover, right? So 0 and 1, that means you have to follow the tutorials, you need to follow the assignments. This should be converted as this, and this should be converted as this. Categorical form, right? So that's one thing. Any other thing, if there is anything to be done other than the categorical form? We are dealing with images. Did you miss any important point? If you can recall what we did for the handwritten digits, is there any other important thing to be done? Yes, we have an answer. Normalize, yes, good. So dividing by 255, can you remember 255? In order to convert the image in between, I mean, in order to convert all the pixel values to a in between value between, sorry, convert all the pixels value to a value in between 0 and 1, we will normalize it, right? So that's one of the most important thing. Okay, all right, so we need to do those things. Okay, so yeah, so here I'm going to first convert them. I mean, we can't do those things without converting data and target into NumPy arrays since they are Python lists. Can you see they are Python lists? So we need to convert it to NumPy arrays first. So I will convert them into NumPy arrays. New data equals np.array data. New target equals np.array target. So we have convert them to NumPy array, and as you mentioned, new data should be divided by 255 in order to convert to a value between 0 and 1. All the pixels will be converting to a value between 0 and 1. Then from keras.utils import nputils, right? And we can then new target equals nputils dot to categorical, and I'm going to pass new target. Okay, now we have what we need now, right? So we have the normalized data, and also we have the what you call the categorical converted targets, right? So this is what we expected, and this is what we are looking for, right? So we have those two. Now then another important thing, the data should be converted into a four-dimensional form, right? So this is one of the important things when we are dealing with convolutional neural networks, right? Okay, now we forgot one thing, right? So I didn't I didn't see how many images were there. Length of data. So we have like 24,400, sorry, 24,946. That means around 54 images are corrupted or not supported, right? So that means that uh, we have lost like 54 images. Understood? Then the important thing, can someone tell me the shape of new data? Shape of new data? Shape. Dimensions of new data? ඔය data කියන එකේ dimensions මොනවද මට කියලා කියන්න පුළුවන්ද? අපි data.newdata.shape කියලා type කරොත් එන්නේ මොකක්ද? newdata.shape කියලා type කරොත් එන්නේ මොකක්ද? That's good. 24,946 3. No. I will give you a hint. Good. Yes, we have an answer, but it's sent by privately. So I will ask from others, right? Okay. Okay, I will give you a hint now. 24,946. That means what? We have 25,946 images in our data set, right? And they are, the resolution of those images is, yes, the resolution of those images is 50 by 50. Yes, good. 50 by 50. So can, the hint is given now. Can you tell me the shape? So that means we have 24,946 50 by 50 images. So what's the shape? So if you have gone through the this handwritten digits, probably you can understand. Yes, good. 24,946, 50, 50, not 3. Why not 3? We convert them into gray. Can you remember? We convert them into gray, right? So that's 24,946, 50, 50, right? Understood? So let me print you. It takes time since we are using the Keras library. For the initial time, it will take some time. Right? So this is the size. Good. Now my point is that convolutional neural networks, we have to input a four-dimensional input when training, right? We have to input a 4D input, right? Now that means if we are going to like the convolutional neural networks are by default they are, I mean, they are designed for color images, right? So what happens when if I mean we didn't convert them into gray images, so the dimensions will be like this, right? Right. So the dimensions will be like this, right? Now this is what the CNN expect from us. මේක තමයි CNN එක අපෙන් බලාපොරොත්තු වෙන dimension එක. මොකද convolutional neural networks by default එයාලා design කරලා තියෙන color images වල. කියන්නේ color කියන්නේ color image එකක් උනත් ගන්න පුළුවන් විදිහ තමයි default size එක. So what we have to do, if we are using gray images, what we have to do, we have to add this one manually. 4D කරන්න එක දාන්න ඕන. gray image එකක් උනත් අපි එක කියලා දාන්න වෙනවා manually. Since convolutional neural network by default they are looking for four-dimensional input, since we like it can train it, I mean it's designed to train for color images as well. So when we are like using gray images, we have to add this one manually. Well, the gray image is kind of a color component kind, so we have to add it manually. Can you explain what's new target variable under Keras? Okay, so you mean this one, right? Yeah, let me. I think this one, right? New target. You are referring to this. Okay, so what we are going to do here. Yes, okay. So now what we are going to do, in our neural network, we have two neurons at the end of the neural network, right? So one for cat, one for dog, right? And we know we are referring cat as, I mean, we are referring cat as 1, sorry, cat as 0, dog as 1. But in the neural network, when the prediction is cat, it should be like this, 1 and 0. If the prediction is dog, right? If the prediction is dog, then it will be like 0, 1, right? So this is called the categorical form. But our data set, I will show you that our data set, let's say the target, I will print the first 10 targets, right? First 10 targets, I mean, not the first 10, but the first 12,500 is cats, right? Are cats. right? So new target, what's the difference? It is not like 0, it's like the categorical form, right? You can see the first 10 targets, 1 0 1 0 1 0 1 0, right? So I will show you the right. පාලස් දාට එහා පැත්තේ තියෙන dogs ඒවනේ. එතකොට අපිට කන්ෆර්ම් කරගන්න පුළුවන්. ඒකින්ද අපි ඒක පෙන්නුවොත් එහෙම එතකොට තියෙන්නේ එක ඒවා. right. එතකොට මෙතන තියෙන්නේ what? Here 0 1. right. The categorical form. Okay. Right. Okay. Yes. Right. So next, what we are going to do, we need to do the dimensions. We have to add the new dimensions, right? So we can do it manually. So new data. I will do it here. Right. New data equals new data dot reshape. New data dot shape shape 0 to comma 1. මට මේක මෙහෙම නැතුව මෙහෙම දෙන්නත් පුළුවන්, right? I can do it manually as well, like this. Right? මට උඩේ කරනකොට මෙහෙම type කරන්නත් පුළුවන්, but I'm not going to do that. Why? What's the reason? I'm not going to do that. I mean, I can directly write it as the code in the last row. Yes, dynamic data, exactly. Not dynamic, yes. I mean, what happened? If you are going to add one image, අලුතෙන් image එකක් දැම්මොත් මේක වෙනස් කරන්න 24947 කියලා. හැබැයි වාට හිතුනොත් එහෙම 50-50 හරියන්නේ නැහැ කියලා 100 කරොත් එහෙම මොකද නේ ආපහු මෙතනට වෙනස් කරන්න. Now, in this code, no need to change anything for a new data set. Right? No need to change anything. Only thing you have to change if you need like change the image size, that's it. Right? No matter if you are going to add images to the images folder, no matter you are going to add a new class, right? No matter. If you are going to add a new class, it doesn't matter, right? It doesn't matter. Everything works dynamically. So this is what you like, what should be there, right? So when you are implementing this, when you are a developer, right, these kind of things should be, this is dynamic. No need to like change anything. You can add new data, you can add new categories as well, you can add a rabbit folder as well. No need to change anything. Everything work well. I mean, no need to change anything. Only if you need to change, what you have to change is the image size, that's all. Right? Understood. Good. So I'm going to run this, and one last thing, np.save data np.save target. Okay, that's it. So what happens, these will be saved as numpy files, physical files. I have saved those arrays to physical files. After numpy save.save use kala make a save kara. Now you can see, I'm not sure about this, but anyway, let me check the dimensions. Yeah, so it's like 59 megabytes, right? So 59 megabytes, we have compressed it to 59 megabytes, right? So target is few kilobytes. Understood. Now this is, we have like reduced the size, and what we have convert the color into gray, so it's like few megabytes, 50 megabytes. Understood. Now we have the physical files. Now no need to give the .npy, right? .npy not needed to, is not required to be given here, since it's automatically added, right? So this is how we are going to. Now what's the purpose of saving these files into a I mean this data set, data and target, to physical files? What's the reason? I mean, can't I type the I mean the neural network, can't I start the neural network training here? Can't I use start the neural network training here? Why I'm going to save it and start it again? Yes, I can, right? I can. I can. I can start implement the neural network. I mean, I have the data and target now, right? So what I have to do? Huh? What I have to do? I have to just split it to train and test, train the neural network and test it. That's all, right? So I am not going to do here. Yes, one purpose is to use it again in a different code or anywhere, or any deployment or any application or whatever the place you want, you can use it. The other thing is, now okay, let's say we are not going to save it to a physical file here, but we are going to starting implementing neural network. We're going to start implementing neural network here. Let's say that we have one error somewhere, right? Neural network එකේ මොකක් හරි වෙනස් කරන්න මොකද ගන්නෙ? ආයෙ මුලින්ම run කරන්නේ සමහර වෙලාවට නේද? So what we have to do, like we have to run the all 25,000 images again, crop it, sorry, resize it, convert gray color, and we are going to මොකද දැන් මෙතනින් පල්ලෙහා යන කෝඩ් එකේ මොකක් හරි අලුත් දෙයක් අප්ඩේට් කරනවා නම් ආයෙ මුලින් ඉඳන් ඔයාලා run කරනවා. You have to. So the safest thing is to save this and finish the code here. So it will save your RAM as well. Now in your RAM, right? So these are some important factors to be considered, right? I now in your RAM. This is my laptop, not my PC. So I think probably it has consumed considerable amount of RAM, since we have 25,000 images in RAM currently, right? Right. So you can see almost 3 GBs, right? Consumed. I will show you something, right? So it's 77 memory of my RAM is used, right? Since now 25,000 images are there in the RAM, we just saved it, but they are in the RAM. Now what happened if you are like try to train the neural network here? Now it's going to take the RAM from the remaining 23, right? So it will like make your computer. I don't know what's going to happen. Sometimes the memory errors will be there. You haven't seen memory errors, right? Yet, when you are dealing with neural networks, your codes are going like freeze, stop, saying memory error. Your RAM is overflow. That kind of thing. So you have to. I mean, we are starting these things, right? So we are starting to deal with huge data sets, right? So eventually uh, we will explore these kind of issues, right? Now, so you have to. I mean, not all the codes are not going to work in your computer. You have like several restrictions. I mean, several limitations about RAM, your CPU, your GPU. Lot of things are to be considered. Now I will clear the output, restart and clear the output. Right, so that will remove everything from your RAM. This code, right? Right. So can you see now it's 59, right? So 59% of my RAM is, so it's all like 20% of the RAM was released, right? Why? Like 25,000 images were there in the RAM, right? Understood now. Those things are like some small things, but keep those things in your mind as well, right? Sometime your computer will get stuck or stops, your ports will be stopped saying memory error. Then that means RAM is overflow. Okay, anyway, now we are safe. What we did, we saved whatever the data and target into two physical files. Now we are going to do what? We can now start training the neural network. I'll get a new code. So let me change the name 2.0 training the CNN. Training the CNN, right? Training the CNN. Okay. So then what I'm going to do first, you have to get the right. So you have to get the two files that you just saved right into the memory and then start training the neural network, right? Then start training the neural network. Okay. So yes, so let me load it now. The code that you are going to use to load the numpy arrays that you just saved, right? You can use the numpy array, so numpy library, numpy as np and data np.load. But now you have to do the npy extension. Right? So this is how we are going to load the data set. So it will be loaded back to your, I mean, your new code, right? Your new code, it will be loaded into a new code. Then what we are going to do, that's probably it. Then we can start implementing the neural network. So from Keras, as usual, models, import sequential, right? And is it as simple? I'm not sure. Okay, from keras.layers, import dense. You know dense layers, right? Yeah, we have to split the data as well. I will do it later after implement the neural network. So dense and so can you remember the dense layers, right? Can you remember the dense layers? What do you mean by dense layer? A dense layer is refers to what? Huh? Is refers to a yes, a fully connected layer, right? A fully connected layer. Good. Now, yes. Now the new type of layers, convolutional 2D and max pooling. I'm not sure about the spellings, but I hope these are the keywords, right? Convolutional 2D. Now, as I mentioned, we have convolution 2D convolution layers, 3D convolution layers, and 1D convolution layers. 1D, 3D, 1D, 2D, and 3D. We are familiar with 2D. We discussed about 2D kernels last time, right? But we have 1D kernels as well. I'm going to discuss about it in probably on 2 weeks, right? Probably on 2 weeks. 3D also will be discussed. I'm not sure, but keep that thing in mind that 1D and 3D convolutional layers are also there, right? Now, if you are using convolutional 1D, you have to use pool 1D, max pooling 1D. If you are using convolution 3D, you will have to use max pooling 3D, right? So that's something going in parallel, right? Why didn't we save new? Yes, okay. There was a mistake, a huge mistake was done by me, right? So we have to save not data, we have to save new data and new target. Okay, so that what we have to do, we have run all. Anyway, we will run it and we will implement this. So it will take few minutes and then we can. Thank you for uh, highlighting that. Okay, so I will create the model. Model equals sequential. Empty neural network will be created here. And the first layer, model.add, I'm going to add a convolutional layer, convolutional 2D, right? Convolutional 2D layer. And we have to give the size of the kernels. So we will use 3 by 3. And I'm going to use like first 256 kernels. So this means what? We have 256 3 by 3 kernels. Now, these are to be studied with whatever things that we discussed on the last lecture, right? So 3 by 3 kernels, 256 3 by 3 kernels. 3 by 3 kernels 256ක් තමයි පළවෙනි එකේ තියෙන්නේ. Right? And yes. Then input dimension, input dim, I can remember input dim or input shape. I think input shape. Input shape. I'm not sure. Let's see. Input shape equals data dot shape 1. What do you mean by this? Now the data here one should be added. අලුත් එක save කළාම මෙතන 24950 50 කියලා එනවා. අපි මොකද මෙතනින් කියන්නේ? එකේ ඉඳන් ගන්න කියලා. එකේ ඉඳන් කියන්නේ 50 51. ඒ කියන්නේ so the neural network is going to take an input of 50 51, right? So that's what mentioned here as the input shape, right? Input shape කියන එකේ 1 ඉඳන් ගන්න. 1 කියලා කියන්නේ 50 50 1 එකකුත් වෙනවා. එතකොට so the first element, first, second, and the third element will be taken. I will show it after this is finished. Right? Then you have to mention the. Yeah, I think that's it. I mean, that's not all. I'm in the first layer. Then we have like add. Yeah, a ReLU layer from Keras dot. I think it's in the activation. Activation, yes. Activation. Yeah, we have an error here. Okay, that's the error with the dimensions. Now, can you see it's specifically said input 0 is incompatible with expected n dimension 4 found n dimension 3. Then make it 3යිනේ තියෙන්නේ 50 51 නේ. ඒතකොට අර කට්ටිය හතරක් ඉල්ලනවා. 50 50 50 50 විතරනේ 50 51. Now it will be there when we run this and save the new data and new target. Right? So now it's going to give us error. So then we have to now can you remember usually what's there after convolution neural network? Sorry, convolutional layer. Usually after convolutional layer, what we are going to like have after convolution layer, what we are going to have? Convolutional layer එකකින් පස්සේ මොකක්ද අපි දාන්නේ? Yes, anyone quickly? Convolution layer followed by what? Yes, good, we have answer. No, no, I'm asking after, immediately after convolution layer. Yes, it is ReLU, right? Or the activation, or the ReLU activation. We have to have a ReLU activation, and then we have to right. So then we have to then have the max pooling, right? Okay. So then we are going to have the active ReLU layer activation, right? Activation ReLU. Yes, we have an answer. Sorry, a question probably. Yes. Yeah, this also possible. You can have the activation in the same layer. It's also possible, or you can have it different. I mean, as a layer as well. You can have it in the same one. I mean, like this activation ReLU. You can do it as well. That as well. Okay. Okay. Then let me add the max pooling layer. Max pooling 2D. Then you have to mention the pool size. Pool size. Okay, so this is the first set of layers. Then we can add another layer. I mean, I'm just randomly adding, right? No theory behind. I'm just randomly adding. Then probably you can have one other layer. I'm just randomly adding. No need like have 3 by 3. You can have 5 by 5, right? Anything. I'm just randomly adding, but no need to have this. Right? Okay. So I just add 3 convolution layers, right? 3 convolution layers of kernels 256, 128, right? I mean, if you need like change these things, you can, right? And it doesn't matter. You can change those things. I'm just like having a random convolution neural network. Okay. Just let's assume that, okay, we are going to have only 3 convolution layers here. We are going to have only 3 convolution layers here. So then if that's the case, what we need to add then, අපි හිතමුකෝ convolution layers 3යි තියෙන අපේ neural network එකේ කියලා. එහෙමනම් අපි ඊළඟට දාන්න ඕනේ මොකද්ද? Just quickly. Yes. Dense layers, yes. Okay. In order to before adding dense layers, what's the right? Before adding a dense layer, yes, it's true dense layer. But how we are going to convert these convolutions into a dense layer? Flat the image, yes. So we are going to use what? What type of layer? So there is a specific type of images, yes. Sorry, not images, sorry. I mean, uh, I mean layer, right? So there's a specific type of layer, yes. Here you have to use a keyword you call pool size. Just can you remember the flatten layer, right? So you have to add the flatten layer, right? So that's what going to convert these into dense layers, right? Dense, I mean neurons. Model dot add flatten, and then we can have whatever uh, dense layers as we want. I'm just adding, right? So no theory behind. I'm just adding. Finally, how many neurons should be there? Yes, finally, how many neurons in the final layer? 2. The activation function. Obvious things. Yes, quickly. Softmax, good. Okay, right. Then shall we take the model dot summary? Okay, now I need to get this again. Data should be taken here. Yeah, right. So now it's okay. So let me clear the memory here, otherwise it will get stuck. Now it's already right doing. Okay, now let me run this. Okay, so it says an error, giving an error. So yeah, model dot condition 256 input shape equals data dot shape. What's the error there? Uh, uh, the thing is now I have made a mistake here. Now this should be like, first we have to give the number of kernels, right? First number of kernels, then the size. First number of kernels, then the size. Right? So first number of kernels, then the size. And yes, as you mentioned, we need to compile this as well. Model dot compile. I have to give the loss entropy and the optimizer. The optimizer I have to give. Let's use the Adam optimizer, and then we have to mention the metrics, accuracy, right? Okay, let's see whether it's going to work. A syntax error is there. I think probably I have yes, one. Okay, 256. So it's 256 3 by 3, and yeah, I think here one additional. Yeah, I think now it works, right? Okay. Right. So okay. So now, right. So we have altogether 1 million trainable parameters here, right? 1 million trainable parameters, right? So you can see layer by layer, it says the kernel sizes and other stuff, right? So layer by layer, I mean, we have like all together 1 million trainable parameters here, 1 million trainable parameters. Now what we can do, uh, we can divide the data set. Yeah, so we can divide the data set now using model selection in sklearn, train import train text split and train data, train target, test data, test target equals train test split, data target, test size equal 0.1, right? So then what I can do, I can model dot fit train data, train target, let's say 20 epochs, and I'm going to add a new parameter as well, validation split. Validation is split 0.2. Validation split 0.2. Right? Okay, now let me train it. I will explain what validation split later. So can you remember last time I mentioned that yes, so last time I mentioned that we have training, testing, and validation. So I will explain what's validation now, but before I will run this code and show you. Sorry, this should be train data, test data, train target, test target. Okay, good. Now, can you see? right? So what this means, huh? Right? So it's take for a single epoch, estimated time, right, is almost 20 minutes for a single epoch, right? Can you see? Now I can hear that all of my fans in this computer started working. So I will show you the CPU usage as CPU usage as well. Right. So can you see now? Not the RAM. Yes, RAM is also consumed, but can you see the CPU? It's 99%. That means 99% of my CPU is used here. What's the reason? Why CPU use? What's the reason for using CPU when a neural network is trained? Why it's using CPU? I mean, not I mean almost all the available CPU we used. What's the reason? Anyone? Why CPU is used? Now, can you remember? Yes, yes, yes. We have a lot of answers. Yes, the thing is now. I mean, can you see? Can you remember from the first 2 weeks, first 3 weeks, right? When a neural network is training for each image, right? For each image, how many weights should be adjusted? 1 million weights should be adjusted, right? So how many calculations should be done for single image, single training instance, right? Millions of calculations should be done, right? So CPU is used, right? So that's the issue with neural networks now. Last time we like the scikit-learn data, I mean the iris flower data set, it took like few seconds to train, right? Here we have images, an image in a single image, we are like using 50 by 50 image. We have 1 million trainable parameters to train. So can you see it takes like understood, right? So this is the issue when you are coming to neural network now. Last time it's fine, but when you are practically coming into this one, this is the issue, right? So what are the solutions, right? The solution number one, if you are having a GPU in your computer, you can use the GPU, the graphical processing unit. Uh, you can allow the graphical processing units to do these calculations, this processing, right? So instead of the CPU, these calculations will be done in parallel in GPU, the graphical processing unit, right? So, but thing is, another limitation is there that you have to have a NVIDIA GPU, right? Only for now, only the NVIDIA GPUs are supported for TensorFlow and also Keras. But another thing now, all the GPUs are not supported for TensorFlow. I mean, even your GPU is NVIDIA, it doesn't mean that it's going to support TensorFlow. Only some of the specific models are supported. So what I'm going to do, if you have a GPU, NVIDIA GPU, you can set up TensorFlow GPU version. Now, what we have installed is TensorFlow CPU version, right? So you can configure the TensorFlow GPU version. So it will like 100 times faster than this, 10 times, 100 times faster than this, right? I mean, if you have a GPU, I mean, with the performance of the GPU, the time taken will be reduced. GPU එක හොඳ වෙන්න යන time එක අඩු වෙනවා, right? So if you have a TensorFlow GPU in your computer, it will solve this issue, right? I mean, it will reduce, but it depend on your uh, the, the the type of the GPU you are having, right? And the other thing is, I will post you a video, right? YouTube video on how to configure TensorFlow GPU version in your computer. So basically, what you have to do is you have to download several plugins and you have to update your GPU, right? You have to update your GPU the latest version, and some you have to install some CUDA libraries. That's all. It will solve this, and it will allow the neural network to be trained on GPU, right? So that one solution. The other one is that you can uh, use a cloud GPU, right? No need to physically buy a one. You can use a cloud GPU. Now, these things are available, right? And you have like for $1 per hour, right? Starting from $1 per hour, and less than that also available, right? So starting, let's say $1 per hour, you can buy cloud computers, right? Dedicated cloud computers. Then you can train it on there as well. Yes, right. So the cloud computers available in AWS, right? AWS, Microsoft Azure, and Google Cloud Services. And the other one is this is one of the new cloud computer providers, cloud GPU providers, uh, Linode. Linode, I can remember as Linode. So it also provides. Uh, let me check. Yes, Linode, I think Linode. So those provides cloud computers where you can. I will do a tutorial on how to uh, train these on cloud servers, but you have to pay, right? You have to pay like hourly rate or monthly or like yearly. But hourly rate you can go up. You can go from like $1 per hour, right? So these will be like this will take only 1 minute. This kind of a thing, even less than that, right? Otherwise, you can have a free version with limitations, right? We can use a free clouds. We can use free cloud servers, cloud GPUs with limitations. So the best thing to use is Google Colab, right? Best one to use is Google Colab. I will show you how to configure Google Colab to train this model, the same model, right? So I'll stop it here, and right, I will stop it here, and I will go to the Google Colab. Now, Google Colab, I no need to pay, right? No need to pay. But since it's free, right? Since it's free, we have lots of limitations like the login time, and we don't have dedicated GPUs. After dedicated GPUs, we can dedicated GPU. අපි ගෙවලා ගන්නවා නම් අපිට හැම dedicated දේවල්. Dedicated කියලා කියන්නේ يعني අපිට කම්පියුටර් එකක්ම ගන්නවා වගේ. hourly ගෙවලා අපි කම්පියුටර් එකක් ගන්නවා. So dedicated in the sense like we are going to get our own computer. No one is sharing anything with us, right? But in these free versions, we have like shared computers. That means same computer is used some by some other as well. So our program is running in one thread, others program is running in one thread, and also this get disconnected, right? We can't like hold it for several hours; it will get disconnected. So, and the RAM is like 70 or 40, 70 gigabytes, and I can't remember. Yeah, the storage, the memory, the hard disk or the storage we are going to get is like 50 GB. The Google Drive, we are going to get the Google Drive as our storage, and yes, we have some other limitations as well. But if you are going to buy uh, for hourly rate or whatever the payment method, then you have your own dedicated thing, right? So if you are like doing a real application, a real project, a real research, right? So worth paying and getting, since the time is like critical, then you can buy it. Otherwise, don't do it for practice, right? No use. You can use Google Colab. So how to configure Google Colab? Uh, so search for Google Colab and you will find it here, right? So then what you can do, you can get a new notebook, right? So new notebook is basically we are using a Jupyter notebook kind of a thing, similar to Jupyter notebook. This is quite similar to Jupyter notebook, right? So you can code, right? You can code using the libraries. Now, no need to install the libraries since they are already installed here, right? They are already installed. No need to install it. Now, we are not running it in our computer. We are running it in cloud computer, right? Or else what you can do, you can upload your already existing notebook, right? You can upload, or even from GitHub you can get, right, directly, or you can upload it to the Google Drive, or you can get the examples available, or you can directly upload from your computer, right? So you can upload the notebook from your computer. You can directly upload it from your computer, as I mentioned, right? So same code will be uploaded. Now the thing here is that now in order to run this, what you have to do, we have to like now our this data and target should be also uploaded to the uh, cloud, right? So how you can do that? You have to upload it to your Google Drive separately, right? So you can upload it to your Google Drive separately, right? So I'm going to go to the Google Drive, and you can create a folder or whatever thing, you can upload it, right? You can upload those files, right? I mean, the data and target, these two can be uploaded, right? So these two can be uploaded here. Understood? Now, I have already, I think, uploaded these things for the previous class. Um, I think it's in my personal. Uh, right, so you can see I have already uploaded. Now you can upload it, right? So cats and dog data, I have this data and target, right? So what you can do now, this is in my Google Drive. What are the NVIDIA GPU versions? TensorFlow supported GPU. Right? here. Right, so these are the supported, right? So you can, I mean, also GeForce here, GeForce and Titan also supported, right? So these are supported, right? So you can have a look later. I will post the full tutorial on how to configure your GPU, right? And you can check your GPU. You know that how to do, right? You can simply uh, check it in the task manager as well. Otherwise, if you can have the NVIDIA control center, you can probably from here you can update it as well. Okay. Yeah. Sorry, I don't have a GPU here in this one, so that's why it's not shown here. Okay. Anyway, so better I think if I can remove the memory. Okay, now I have uploaded to my Google Drive, right? So what you can do here, the data and target is uploaded here. So you can upload any file to the Google Drive, and what you have to do here, go here and sorry, not here, this one, this folder button, right? So now can you see it's connecting, still it's connected to a runtime. Now we are like using free version, so we have like wait few minutes, now it's connected. Now this runtime is a temporary runtime. Now with sometimes it get disconnected, right? So you can change the runtime from here, uh, like change the runtime type. So you have to use the hardware accelerator none. When it's used none, like it's going to use the CPU or general CPU. If you can put GPU, then the GPU graphical processing unit will be. But the thing is now they have not mentioned what's the GPU that they are using. Or you can use a TPU. TPU is tensor processing unit. Tensor processing units are specifically designed for neural network training, right? So GPU is sufficient in this case. And so you have to first change the run type, as I mentioned. Now we have to like then wait few seconds since now it's connected. Now here you can see when it's connected, now the runtime is there. Now what you have to do, you have to mount the drive. So this will mount. I will put this down now. Yes. Okay. So then when you are going to press mount drive here, this code will be appeared. Now you have to first run it, right? You have to first run it. Now what you are going to do, we have to get this, right? You have to get this link, go to that link and log into your Google account, right? And then allow. Then you have a token, right? You have to copy this token and come back here. Come back here and paste the token here, right? Now the Colab is going to be connected with your Google Drive, right? So it's connected to the Google Drive. Now the Colab and the Google Drive are connected. Now what you can do, you can hit on refresh here, hit on refresh, then your drive will be appeared. Then go to drive, go to my drive, and now this is your Google Drive, right? Then I have my folder here, cats and dogs data, then data and target are here. So what I'm going to do, copy the path and give the path here. And also copy the path of this one and give it here. Right, so that's it. Now what you can do, the Colab will load it from your drive. So now this is the, this is the main thing, this is the main purpose that I write the data and target into physical file. So you can upload it to the Google Colab. Now again, Google Colab is a free cloud service available, right? So we have like paid versions as well, but for our application, simple applications, it's sufficient. If we are dealing with a real application, real complex and big application, right? So then you can probably buy paid dedicated cloud services, right? AWS, uh, Microsoft Azure, Google Cloud Services, and also Linode, the new one, and it's also like have cheap computers, right? Then let us do the right. See how fast it's already taking like 1 minute, right? Not even 1 minute, few seconds, right? Taking like 10 seconds, right? So that's the power of GPUs. Now we are using cloud GPU, but it's like now accuracy is raised up to like 77, right? So you can see it, right? Right. So the model is training. Now I will talk about the validation. What do you mean by the validation data, right? So here, can you see in the model.fit, right? In the model.fit, what we are trying to do here is that uh, you can see I'm going to train the neural network and I have given validation split 0.2. It can be like 0.1 as well. You can give anything. Now, you know what's train test split. We are keeping, we are splitting the data set into training and testing, right? And from the training data, we are going to train it, right? And after it's been trained, we can use the test data to test the neural network and get the accuracy and others, right? Now, what you mean by validation is a similar idea, but it's different. That means, okay, it's working for single epoch like this. Okay, we are going to run the first epoch, right? So when you are going to provide train data and train target, here another split will be done. Our split එකක් කරනවා. මේ train data train target කියන එක දෙකම බෙදනවා දෙකකට. Right? So it's like this. So train data and also train target. Right? So these will be again divided to train and validation. Okay, now it's like 80% for training 20% for validation. Now here, like we have data, and from data we got 90% for training, and for testing you can see we got like 10%, right? So that's another thing. From this 90%, again we are going to like split 80 and 20 for training and validation. Our train data එක තමයි ආය දෙකට බෙදන්නේ training and validation, right? So what we are going to do here now, we are going to split 80% to training again, and we keep 20% for validation. Now we are not going to train the neural network on the validation 20%. අර 120ක් තියෙන validation වලින් අපි train කරන්නේ නැහැ neural network. We are not going to train it from the validation data. What we are going to do, we are going to keep it. That means for the neural network, it's unseen data, right? For the neural network, it's unseen data. Neural network එක දැක්කේ නැහැ. ඒකට එකෙන් train වෙන්නේ නැහැ. 180කින් තමයි යා train වෙන්නේ. අර ආපු train data and train target වලින් 180කින් තමයි train වෙන්නේ. Right? So what we are going to do after each epoch, right? After each, now keep the idea. After each epoch, we are going to add the validation data and get the results and compare it with the validation target and get the accuracy and the loss. 180ක් දානවා training වලට, ඊටු 100 training එකට දාන්නේ නැහැ මෙතන, right? testing එක වෙනම කතාවක්. ඒක කොහොමද කලින් අයින් කරපු එකක් නේ. දැන් මේ ආපු training වලිනුත් 180ක් තියාගෙන 120ක් මෙයා 180ක් දානවා 120ක් තියාගන්න. 180ෙන් train කරලා ඉවර වෙලා ඒ epoch එක ඉවර වෙනවා. I'm talking about epoch. epoch එක ඉවර වෙනවා මොකද කරන්නේ? validation දාලා neural network එකට දාලා test කරලා end results with actual results with compare කරලා බලලා එතන accuracy එක බලනවා. So that's called the validation accuracy, and the loss is called the validation loss. Understood? Now this is done for each and every epoch, right? And the same validation data will be tested after the, right? After the what? The second epoch. And the same validation data will be tested after the third epoch, fourth epoch. After each and every epoch, we are going to pass this unseen data, right? We are going to pass this unseen data and test it, right? So validation data is unseen, right? So what's the purpose of doing this? After every epoch, we are going to keep a track on the validation. Now this is one of the most important things when you are dealing with neural networks, the concept of validation, right? So it's like this, okay? හැම epoch එකකටම වතාවක් අපි දාන්නේ එකම data set එකනේ හැම epoch එකේදී. පළවෙනි epoch එකේ දාපු එකමයි දෙවෙනි epoch එකේ දාන්නේ. ඒකමයි තුන්වෙනි epoch එකේ දාන්නේ. Right? So the neural network is after the first epoch, neural network will be trained on seen data. So it's going to see it again and again. So it's like we are doing a past paper again and again and again. Right? So it's like we are doing a past paper again and again. Right? So with the time, what we are going to do? What's going to happen? By heart, we are going to memorize it. නේද? අපි by heart එක අපිට මතක තියෙනවා. මේක දැකලා තියෙනවා කලිනුත් දැක්ක මේ. ඒතකොට ඔයා හිතන්න පාස් පේපර් එකක් 10 පාරක් විතර කළාම ඔයාලට පාස් පේපර් එක බලන්න නැතුව උත්තර ලියන්න පුළුවන්. Right, so that kind of confidence you are going to get by doing the same thing and same thing again and again, right? So it's a common thing. The accuracy is going to be increased. Accuracy කොහොමද පරිණාම මොකද මේ ආපහු එකම දේ දකින්නේ, right? අපි එහෙම වුණාම මොකද වෙන්නේ? දැන් exam එකක අපි මෙහෙම දෙයක් කරනවා. හරි. past papers වලින් පාඩම් ගන්න. හැබැයි like okay, you can train on past papers, but after every week I'm going to give you some unseen data to test you. ඔයා දැකපු නැති ප්‍රශ්න ටිකක් මම ඔයාලට දීලා බලන හැම සතියකම ඔයාලා ටෙස්ට් කරන්න. Right? Understood? Right? So now what we are going to do, we are going to keep some unseen data. Now it's called the validation data, and after every epoch we are going to apply it, get the results and compare and get the accuracy and loss. So that's called validation, right? So in validation, yes. Yes, it's like cross-fold validation, K-fold. Yes, exactly. Not exactly, but yes, quite similar, right? So what are the important things we can, I think it's not very much visible here. Okay, let me, okay. So we can visualize this accuracy and validation by a plot. We are going to plot the loss and the validation loss on the same graph. And also the accuracy and the validation accuracy. Okay. So what you, I mean, so the orange color is the validation loss and the green color is the, I mean, yeah, as I mentioned in the previous weeks as well, we are like vigilant about the loss, not the accuracy, right? So we also like always we need to like keep I mean, we are interested on the acute loss, right? So we need to minimize the loss. That's the purpose, not maximize the accuracy. I mean, minimizing the loss is will lead to maximizing the accuracy, right? So it's something going to happen. So our focus is on minimizing the loss, right? I discussed about this few times earlier. Now, what this means, right? So your loss is decreasing, but your validation loss is increasing. This means what? Huh? This means, yes, this is called the overfitting, the most critical and the most usual problem in training the neural networks now. Okay, last time we just, okay, we were happy, okay, we are getting like 99% accuracy, right? We got like 99% accuracy for all the training we done. No, it's not like that. It's like doing the same past paper again and again and getting 99 marks, right? So here, this is what we want, right? What we are going to do, we are going to do the past papers. We are going to do the past papers again and again, right? We are going to do the same data again and again. We are going to train on same data and again and again. But in regular intervals, we are going to test our neural network using unseen data and get the predicted results and get the accuracy and the loss compare. And this is what we got. Okay. So in case of the accuracy, what this means, okay, past papers වල ගන්න ලකුණු එන්න වැඩි වෙනවා. හැබැයි දැකපු නැති ප්‍රශ්න දුන්නාම ගන්න ලකුණු අඩු වෙනවා පොඩ්ඩ පොඩ්ඩ. So like it's not a training, right? So it's overfitting. It's called the overfitting. It's overfitting to the training data. Past paper එකම පාඩම් වෙලා දැකපු data වලටම මෙයා පුරුදු වෙලා අලුත් data දැක්කට මෙයාට predict කරන්න බෑ. Right? So this is called the overfitting. Right? So one of the most critical issues in neural networks. Common issue. Common problem, not issue actually. Right? Right? So in order to identify the overfitting, you can so this is called like overfitting, since now it's fitted to the training data. Training data වලටම පුරුදු වෙලා එයාට හරියට දෙනවා. හැබැයි අලුත් අකපු නැති ඒවාට මෙයාට හරියට වෙයිට් කරන්න බෑ. ඒතකොට training data වලටම overfit වෙලා කියලා අපි කියනවා. Right? Overfit. Now this should be like this. Right? I mean, it should be like this. So I'm drawing this in the same color, right? So it should be like this. If this is the case, it's fine. This is fine, right? Or this is also fine. I mean, the validation loss can be smaller than the loss. It can be happen, right? Or else if this can be also happen. This kind of thing. So this kind of thing can be happen. The point is the loss, when the loss is decreasing, validation loss also should be decreased. It's no matter whether it's like this, right? Or it's like this, no matter. So the point is, this is okay. This is okay in the sense, when loss is decreasing, validation's loss is should be decreased. Loss එක අඩු වෙනකොට validation loss එකත් අඩු වෙන්න ඕනේ. මම කියන්නේ නැහැ. Loss එකට වඩා validation loss එක අඩු වෙන්න ඕනේ කියලා කියන්නේ නැහැ. Loss එක අඩු වෙනකොට validation loss එකත් අඩු වෙන්න ඕනේ. අරකට වඩා වැඩි වුණාට කවන්න ඒකට අඩු වෙන්න ඕනේ. අඩු වේගන යනවා. දැන් මෙතන එහෙමනේ, right? So when the loss is decreasing, validation loss is also decreasing with the loss. I mean, I'm not saying that the validation loss should be less than the training loss. No, not like that, but it should be decreased with the number of epochs increasing, the increment of the number of epochs. And this is okay. So this is where the problem is. Right? So this is where the problem is. Okay, how to solve here other than limiting the training? Yes, we have several options to overcome this issue. I will explain them. So if this is the loss, and if this is the validation loss, oh, now it's the matter. So this is not acceptable. This is called overfitting. This is called overfitting of neural networks. Right? So this is called the overfitting of neural networks. So what's the point? When the training loss is decreasing, right? When the training loss is decreasing, if your validation loss is going to increase, that's called overfitting. Now you can see it by looking at the graphs, right? So our problem is definitely, you can see it's suffering from overfitting. Our neural network is suffering from overfitting, not our neural network. And almost all the neural networks, I mean, majority when we are dealing with convolutional neural networks, they are overfitting, right? Right? So they are overfitting. So what we can do, right? So we have like several options of overcoming this issue, right? And this is the issue. I mean, what's the issue, right? What will happen? I mean, when it's going, I mean, this is, can you understand? This is the issue. That means not giving correct results for unseen data. Yes, it's a problem. Why? Now, when we are going to train a neural network, okay, for self-driving car, okay, we are going to train it in Colombo, or we are not, we are going to train it in Gaul, right? So we are going to train it in Gaul and Mathur. So when we are going to test it in Kurnagar, unseen data, right? It's not giving the correct predictions, right? Understood? So it's going to be definitely, it's going to be a matter, right? So unseen data now, when we are going to have, okay, so let's say we are building up a, what you call this, trading bot, right? Stock market value prediction. So it's going to, okay, so training data is giving correct prediction. Now when we are going to apply it to the stock market, it's not going to give correct predictions for unseen data, right? So it's definitely a problem, right? Okay, so we have several options of overcoming this issue, right? The first one is overcoming overfitting, right? The first one is to the most, right, the simplest solution, early stopping. Early stopping. What do you mean early stopping? Now, can you see where the overfitting started here, right? Right? Where the overfitting started here. So what we are going to do? We are going to limit our neural network for 6 epochs. We are going to limit the training for 6 epochs, right? But what's the disadvantage of doing that? I mean, what's the issue with that? Huh? Okay, we are going to stop it here. So what's the minimum loss we have achieved? Here, right? I mean, we have the possibility of minimizing the error further, but we are, right? We are, yes, we are not, the neural network is not optimized. So that's not the, I mean, that's not uh, the recommended solution, but it's a solution. Yeah, it's a solution by theory, right? Not by me. It's a solution by theory. Then the next promised method of doing this is to use this kind of a magic, dropout layers. Drop out layers. Use dropout layers, right? So what do you mean by a dropout layer? A simple theory, a simple idea, but giving unbelievable results, right? Giving unbelievable results. Right? So in dropout, I mean, the theory, it says this is like this can reduce overfitting. It can reduce overfitting. Now this is what you call dropout. In between two layers, two layers, for each training epochs, you are going to deactivate randomly selected neurons. Neural network එකේ train වෙන හැම පාරකටම layers අතර තියෙන neurons randomly pick කරගෙන deactivate කරනවා. ඒ කියන්නේ ඒවා වහලා දානවා. ඒ කියන්නේ ඒකෙන් ඒවා අප්ඩේට් වෙන්නේ නැත්නම් ඒ වගේ values යන්නේ නැහැ. ඒ වගේ values pass වෙන්නේ නැහැ. forward propagate වෙන්නේ නැහැ and backward propagate වෙන්නේත් නැහැ. සමහර neurons. Right? The thing is now it's not like selected set of neurons. No. For each training instant හැම training හැම දාන image එකකට වතාවක්ම layers ටිකක් අතරේ සමහර neurons deactivate කරනවා. freeze කරනවා. සමහර neurons. ඊළඟ පාර වෙන neuron set එකක් freeze කරනවා. Right? So this is called the dropout layer. Now, I mean, okay, a strange idea, right? So how this is going to overcome? I mean, how come this reduce the validation loss? I mean, not the validation loss, the overfitting. I mean, what we are trying to do here, we are making the neural network's life hard, right? අපි neural network එක train වෙන එක අමාරු කරනවා. සමහර තැන්වලදී සමහර ඒවා train කරන්නේ නැහැ. Right? So this is going to reduce the overfitting. So we are making the neural network's life hard, and we are like by force we are like making the life hard, and we are like sometime for each training instant we are freezing some neurons. So those will not be trained. So this is going to reduce the overfitting, right? So I will show you and I will explain more, right? So how you can add dropout layers like this. So dropout layers are usually added between dense layers, right? So dropout is a layer type. So I'm going to add dropout layers here, model.add. And you have to mention the dropout probability. Dropout probability. So what do you mean by dropout probability is, let me add other between other layers as well. Right? So what we mean by the dropout probability 0.5, that means 50%. That means 50% of neurons in between this flattened layer and this dense layer, for each instant 50% of the neurons will be deactivated. Randomly selected 50% of the neurons will be deactivated for each training instant. Right? So dropout layers are applied in between two layers. Right? So let us train this and see the results. Now you can see the accuracy is not that much increasing. I mean, like the earlier case, right? I can remember, as I can remember, in the earlier case, like in the second epoch, it reached like 80% or 60%, right? But 60 or 70%, I can't remember. But this is like not going that much. The accuracy is not, or the loss is not that much decreasing. That means this is learning, this is training bit harder than the earlier case, right? So this is we have made the life complicated for the neural network. But let's see what's going to happen. Right? Yes, you can. Yes, you can have dropout layers in between convolution layers as well, but it's not done usually. You can do, but I don't know whether it's going to give a. I can't remember whether it's going to give like different results, but we can try it out. But it's recommended, always it's recommended to use dropout layers in between dense layers. Now you can see it's like not reaching 90%, right? But anyway, we have made the life hard, but anyway, like let's see if we are getting good results, then it's fine. Can you see it's better than the earlier guess, right? Right? So can you see it's better than the earlier guess? Now we can see a like very, I mean, clear difference, right? So it was like earlier it's like this. Now it's like flattening it, right? I'm not sure whether. Let's see. Let's check the accuracy. Yes, now accuracy is good, right? Quite good. But now the thing is, now it has only reached like up to 90. You can train it more for more epochs, but you can see now the curve is bit flattened, right? I mean, it's going with the loss, right? I'm not sure whether I have used too much of dropout layers. Let me, I mean, sometimes using too much of dropout layers is going to be another matter. Uh, Let me have dropout layers in between these two. Sometimes having more, I mean, too much dropout layers again going to be a matter, right? So I'm not sure. We will anyway, we will see. That's why we'll see it. And yes, meanwhile, I can. Yes, yes, exactly. That's what we are going to. Okay, we have a question. I think everyone can see it, right? Uh, okay, I will. No, I will send. I will present the question. So until we get the best results, we will be keep trying by changing different parameters. Yes, exactly. That's what I'm like mentioning from the first week. Now this is some like we have to do it again and again, right? Several times, right? I mean, as I mentioned, no theory is to prove that okay, this is the best thing, this is the best thing. So you have trained this, and now see, let's say if you are like spending 1 hour to train a neural network, You have to wait 1 hour to train one parameter. එක parameter එක අපි neural net එකෙන් pack යනවා. ඒ pack වල ආයෙත් ඊළඟ parameter එක වෙනස් කරනවා. So this takes time, right? So I mean, by one shot, it's not going to work, right? So this is why this takes time, right? So keep that thing in mind. Those are quite important. I mean, uh, like we have to do it and do it again and again. So if you are like dealing with a real project, like a real implementation, then probably you have to buy, like you have to spend money, right? You spend money and buy these, I mean, computers, right, or cloud computers, and train these things. Otherwise, in your normal CPU, it would take like days to train a neural network, right? A convolution type neural network. Understood? So the best thing is to, yes. How to decide on how many epochs to run? Yes, so this is something I mentioned earlier as well. Like this is the usual case. The number of epochs should be selected on this one. I mean, you have to check whether your neural network is optimized or not. Right? I mean, first you have to check for the validation loss and make sure that the neural network is not suffering from the. First, you have to get rid of overfitting. That's the most important thing. Somehow, you have to make these curves close. Right? That's something that you need to do. You have like, okay, this is if the training, and if this is the whatever, this is the training, and let's say this is the validation. You have like somehow make these two close. I mean, no need to do it like this. Like this would be fine, or like this would be fine. It's fine. I mean, here to like the loss should be, both loss should be decreased. And how to find the sufficient, or the how many epochs to run is, first you have to get, if there is overfitting, you have to first get rid of it. ඉස්සලාම overfitting අයින් කරගන්න. ඊට පස්සේ like your, if your loss is something like this, okay, so then you can identify, okay, this is the number of epochs that you need to run this one. Why? The loss is optimized. That means it's not decreasing after this. Right? So this is the number of epochs that you need to run this neural network. Understood? So that's how we are going to select the number of. What if the validation loss is high at that point? Yes, that's what I mentioned. Now, if you have to first get rid of the validation loss, right? Isala validation, sorry, overfitting අයින් කරන්න ඉස්සලා. You have to remove the overfitting. You have to get rid of overfitting first, right? Then you have to select this point. Right? That should be like, we have made sure that the first time, okay, the validation is you ask like this, instant like this. Jeffrey, is it, I mean, you're asking about the instant like this. Now this means the training loss is optimized, but the validation is loss is still decreasing. Okay, my question. If we take the training loss and the validation loss, to which we should give the priority? To the validation loss or the normal training loss? අපි training loss එකයි validation loss එකයි ගත්තාම කාටද priority එක දෙන්න ඕනේ? A binary question. A binary question. 1 or 0, I mean. Okay, one says, puzzle says validation loss. Others? Okay, let's take a vote. Person says validation loss. Others, yes, we have like 14. Without me, 13. Yes. Okay, 2 votes, 3 votes for validation. Sorry, 4 votes. Others? Okay, yes, it's validation loss. We have to give the priority to the validation loss. The validation loss is the important, right? Past papers වල ගන්න ලකුණුද වැදගත් වෙන්නේ වාර්ය භාගයේ ලකුණු ගන්න ලකුණුද වැදගත්. So it's like a question between, okay, is it what's the important thing? The marks you are getting to the uh, past papers or the marks you are getting to the term tests in your school, right? So term tests are unseen data, right? Yes, good. So that's the same thing here, right? So you have to give the priority to the validation loss. Good point raised by Jeffrey. Yes, you have to give the priority, and you have to find the priority to the point of the validation loss, right? Okay, that means, okay, now can someone tell me by looking at this graph, right? Is this the new graph that we got? Anyway, let me see. Is this okay? Anyway, now can someone? Okay, so which epoch got the best results here? Which is the best epoch? Which is the best epoch? uh, 8. No, not 8. It's a bit hard for me as well. Oh, no, not this. I had like a draw a straight line. Okay, let's see. Okay, yeah. So it's 12th. So 12th epochs give the minimum loss. So the 12th epoch. That means what? Okay. Now, what we have to do here, right? Okay. Now, in the last tutorials, I mentioned that we can save the model using model.save weights. Like this, right? Right. Now, what will happen? In this case, this is going to save what? This is going to save the right model weights of which epoch? Huh? This is going to save the weights of the last epoch. That means the 20th epoch. Make a save 20th epoch weights, right? But the best weights are the weights of 12, right? 12th epoch, right? So there is an automated method of saving the best model, right? Saving the best model. I can't exactly recall the code, but so I will, right? I will. Yes, I can't exactly recall the code, but I will get it from. Uh, um, yeah, it's there on my codes. I will quickly get now. What I'm talking about is that there's an automated method of saving the best model. We can monitor the validation loss, and we can save the best model only, right? So that can be done. I have done it in face mask detection as well. Let me see. Yeah, this one. Model.checkpoint. I'll quickly paste it here. Okay. Okay. So we can create a checkpoint, model checkpoint. That means we are going to save each model. We are going to save each model, right? We are going to monitor the validation loss, and here save best only. That means we are going to save the models which has minimum validation loss than the previous epoch. If this epoch is having a smaller, less validation loss than the earlier case, we are going to save it. Otherwise, we are not going to save it, right? Then probably we can get the check. We have to get the checkpoint as well here. Model checkpoint callbacks. Right. So let me run this first once. Now what happened? Now this will be saved in your temporary drive, not the Google Drive. The temporary drive. We are going to getting a temporary drive with the runtime. So it will be saved here. I will show you. Now, anyway, the first one is always the first one. Yeah. Let me restart and run all. So you can see it's saved here. This is not saving in the drive, right? So it's saving in your temporary storage provided by the Google Colab. Now you can see that I'm save and the model one will be definitely saved since it's the only the validation loss, the first validation loss. Then the other models will be saved if the validation loss is greater than less than the earlier case. කලින් epoch එකේ validation loss එකට වඩා මේ epoch එකේ validation loss එක අඩු නම් විතරයි save කරන්නේ. අපි මේ checkpoint එක හදලා තියෙන්නේ. So we have like create a checkpoint like this. So this is the file name that the model will be saved. Model epoch number 03D. That means 03s and the epoch number D 001 003, right? So 3 digits. Dot model. You can use the H5O dot model. I will use this and show you how to get this model and do whatever necessary thing. Then save the best only. True, that means only the best models will be saved. This is what I mentioned. If the validation loss is less than the earlier epoch, then it will be saved. Otherwise, it's not going to be saved. Right. So then you have to give the callbacks here. Right. So you can probably see all the models will be saved here. Now, so you can see after model 8, they have not been saved yet since I think after 8, it's the validation loss is increasing. But 12, I think, as I saw last time, 10 again, 10 is decreased. Other than yes. Anyway, we'll see. Okay, Mike, I have a question. Okay, so if you are going to apply the train neural same data set to a neural network, I mean this is an additional question not related to this. If you are going to apply the same data set to a neural network, I'm going to, in two instances. Okay, instance number 1, I'm going to restart and train on the same data set. Are we going to get two different validation loss or two different losses and two different accuracies? එකම data set එක neural network එක පාරක් දාලා train කරන ඒකම ආයෙ පාරක් දානවා. Are we going to get the we are going to restart everything and we are going to do it again. Are we going to get the same or different results? Different. What's the reason? Yes, what's the reason? Yes, what's the reason? Yes, anyone? Not randomly selected. No, no, I'm asking the same data set. We are not going to change the data set. train test split එකකින් වෙන කතා නෙවෙයි මම කියන්නේ. එකම train data train target දානවා කියලා හිතන්න එකම data දානවා. Same data set will be applied. If the same data set, I'm not going to change the it. I don't consider about the train test split. If you are going to apply the same data set again, what's going to happen? Right? Yes, it will be different now. Why? The weights and biases are randomly selected. That's the point, right? Yes, yes. Weights and biases are random selected. So, right. So, can you see now the model 10 is the best model? So the model 10 is the best model. So what you can do? Now we created our data set. We are not using the Google Colab to create our data set. අපි data set එක හදන්න Google Colab එක use කරන්න ඕන නම් ඔය data set එක හදන්න අපේ GPU එක CPU එක එච්චර යන්නේ නැහැ. Data set එක හදන්න අපිට යන්නේ RAM එක. We need the RAM to create the data set. So what we can do, we can create the data set in our computer and upload it to drive and train the neural network in the cloud, since it takes the CPU and GPU, right? So we need to, I mean, only for training we are using the Google Colab. No need to, like, in order to create the data set, don't use the Colab, right? Now after it's been trained, what we can do? Simply download the best model. Download. Now we are getting it back to our computer, right? So we are like, we have trained the neural network somewhere else and getting the knowledge back to our computer, right? So we can just download it from here. Understood? So see, we can do what we can do with the tools we have, right? And in order to become the, in order to become the, overcome the overfitting, we can do some other things as well. So overfitting, we discuss the early stopping, and also the what you call the dropout layers, and we can use data augmentation, right? Data augmentation, and fourth one is batch normalization, right? So these two things I will discuss it on coming weeks, right? Not today. Data augmentation and batch normalization will be discussed on coming week. What's the right? But the best solution is this, right? But you can use data augmentation and batch normalization as well. So we will discuss about on coming week, right? Okay, so with that, I will conclude the session for today, right? And on next week, Saturday, we are going to take a look on the practical applications of convolutional neural networks. So under that, we will discuss about training a self-driving car. So we will actually train the same model used by the NVIDIA for their self-driving car. We will train the same model using a simulator. We are going to use the simulator and train the same thing. Discuss on how to do that on next week. And also we will start talking about TensorFlow object detection API or object detection APIs, and we will start training an object detection for API for detecting custom objects. That means any object. It can be anything you like. Tomato, it can be banana, it can be like a key, it can be a mobile phone, it can be a watch, it can be anything, right? So you can train an object detection API for detecting anything. I mean, that's for like detect and draw the bounding rectangle, right? So you can read the bounding rectangle. In our case, we are not going to get that bounding rectangle. Our object වටේට bounding rectangle එක අපි මේ අද කරපු එකේ වෙන්නේ නැහැ. හැබැයි අපි එදාට කරන එකේ මේක අපිට බලන්න පුළුවන්, right? So I will check the probability of yes, we have a question. Okay. Yes, so there's a suggestion. If you could give us the details and location where to get the data in advance, we can ready with the resource for coding along. Otherwise, we have to go just what to do. Okay. Yes, so I will consider that. The thing is, I'm having everything in GitHub, but the thing is, yeah. So I will try to show you. Now everything is there in the GitHub. Uh, right, so everything is there in the GitHub. I mean, let's take today. So it is day 4, DLN week 4. Right, but thing is now this is the first course that I'm doing online, and we have two main sessions. The last two courses I conducted were like full day courses. That means Sunday 8:30 to 4:30, 8:30 to 4:30. So in that case, and also I'm going to add new uh, things to this course as well. But everything is there. I can give you this thing, but the thing is sometimes these things will be different, right? So keep that thing in mind. So what you can do, so good. I mean, so before you refer this thing, what I want to say is sometimes now there might be different, or there might be like the codes and some implementations might be different, since we are doing two sessions, right? So practical session and the theory, so the lecture session, right? But this contains everything for week, right? The whole week, right? But another thing, now sometimes things might get added, not removed, but get added. Some advanced things might get added, right? So keep uh, track on that and get this one. So what you have to do, basically I will drop this thing in your group, WhatsApp group. You have to go to this one and go to repository and find the respective, I mean uh, the week, right? Week 5. Now what you are going to do on week 5 is here, right? Right, so everything is there, right? So you can get ready with that. Okay, so good suggestion. And they were already there, right? But I didn't mention this since I didn't mention this actually, since these things might get changed, since this is the first online course I'm teaching, and I'm doing two different sessions for practical and the theory parts, right? Anyway, it's fine. You can have a look. I mean, there might be slight changes, slight differences for the weeks. Some things might get added, right? So you can go to the GitHub, and I will give you the link and go to the repositories and get the week you want. Right? All the 12 weeks are there. Okay, so with that, thank you very much. And if you have any questions, please ask. Right? So we will discuss on next week. I will probably upload a tutorial, I'm not sure. But other than we have, yeah, other than that, we have now this neural network should be tested, right? So we have something to do. We just trained. We had like apply some unseen images and see what the predictions are, right? So that part is there. We didn't do that. I will do it on next week, or I will upload a tutorial. And you have already a tutorial there, right? So please go with this, right? I mean, the hand in the GUI, right? So bit interesting. So you can develop that. It's under tutorials, right? So week 4 tutorials, we have the FFN integrated GUI. So 50 minutes video. So please watch it and try to implement. Okay. So any issues to be discussed or anything to be discussed other than this? Yes. Is there a deadline for the assignment? Yes. I mean, all the assignments should be uploaded as I mentioned in the first week, within 1 week, right? Within 1 week, we have to upload. Otherwise, if you have any like difficulty on uploading in 1 week, please drop me a message. So I will see what we can do, right? So otherwise, it will be like 1 week usually, 1 week time for each assignment. But if you have any difficulty on completing, please let me know. Then I will make the necessary arrangements. Okay, right. So the last week assignment. Now this is a tutorial. No need to do this as assignment. This is a tutorial. Assignments only you have to submit, right? Okay. So any other things to be discussed? I will provide the assignment on this week as well, right? Yes. Any other thing to be discussed? Okay. Discussing the assignment. Okay. Now, you mean the last assignment, right? The week 3 assignment. Okay. Okay. So first, let me go through the submissions, right? So see what you have achieved and what you have done and the results, and let me then discuss your what are the modifications to be done, what are the things to be done, right? Okay. So I will first go through your submissions and then I will let you know anything to be improved or what are the uh, things to be improved and what are things to be added and what are the things we have done wrong, right? So likewise, I will discuss about that thing probably on next week, let's say, right? So any other thing? Okay. Okay. So with that, then I will conclude the session for today. So thank you very much. And is Pavanta here? So who had the problem with the installation? So it was Pavanta, right? He's not here, right? Is it? Yes, he's not here. So anyway, uh, okay, he had a problem with the installation, but he's not here. Okay, I will do something about that. Anyway, okay, so thank you very much and see you on Saturday. So please drop messages if you have any questions on the WhatsApp group or person you can message. Now, I'm quite happy now, like not few, right? Yes, few of you are like directly messaging me and asking questions and how to do this and this. So that means you are working. So that means happy to see that, right? Okay, so please feel free to contact me and clarify doubts if you have any, right? Okay, so thank you very much and meet you on next week.